Hello and welcome to another video. This time we're going to find out about fetching information from the VDP. In particular, trying to find out what colour a pixel is. As usual, the only tools you'll need are Nano and your assembler. If we think back to lesson 6, we were plotting some graphics on the screen. Note that one of those was a single red pixel at 200,80 position. If we look at our code today, most of the start of this is exactly what we've looked at before. We set things up and set the screen mode to 8. And this section is what sent all that data to plot the different graphics on the screen. So moving on, the first thing we're going to do is to make sure that our IX register points to the system variables. I've created a macro called moscall, so that this time it doesn't take 2 lines of code, just one. Now the first thing we need to do is to reset the reply flag. So what do we mean by that? So when we send a command from the Z80 to the VDP to ask for some information, such as the colour of a pixel, we send that command, but the information isn't available immediately. The VDP thinks about it for a few moments. It then sends it back to the Z80 processor, which then stores that in the system variables which we can use. Now don't worry, this doesn't actually take very long, but it isn't instantaneous. We can't just get that information immediately. What we need to do is check that the information has come back. So that's why at first we reset the flag so that we know when we look for it, it's changed. The routine is further down here. It's fairly simple. It just checks the flag for what it currently contains and changes 1 bit within it. So how do we actually send the information off? Well, we're going to do a pixel inquiry, and this is another VDU command that we can send. So I've written a routine here. Let's take a look at it. It's just down here. Like we've sent information before, we load HL with the data we want to send and BC with the length. And this is what we're actually going to send. The command is 230 and then hexadecimal 84. That's for getting the colour of a pixel at a given coordinate. We then follow that with the 2 coordinates. Note that both of these are words, not integers. So once we've sent that, we've then got to wait for that flag to change so we know that a reply has come. So that's where this little routine, wait for flag update, comes in. If we take a look at that down here, again it checks the system variable to see whether bit 2 has changed after we reset it. If it hasn't changed, it just waits here until it has changed, and when it has changed, it then returns. As I've said before, this is all very quick. But if we try to find out the information too quickly, it won't have got updated. So once we know that a flag is updated, we can then check our system variables, and it's plus 16 hexadecimal this time, and that will give us the palette index of the actual colour that we're looking at. Now lesson 6, we learnt how to print some information to the screen. So again we're going to use that here. At 00, we're going to print the hexadecimal value of A on the screen so we can see it. If we go onto the Agon and assemble that file, and load it, and then run, so what do we see? We've got our red pixel on the screen, and it's given us that coordinate we looked up of 200,80, as being number 9. So what does 9 mean? If we go back to our code and scroll down for where we set that pixel, we set a pixel at 280 to be bright red. Now what was bright red? Bright red was 9. So there we are. It's given us the index colour of bright red, and that is the pixel position of that bright red pixel. Try changing the coordinate numbers for yourself and see if you can find the colours of other points on the screen.